Hey everyone, welcome back and let's write some more neat code today. So today let's solve the problem remove duplicates from a sorted array. So while this is an easy problem, it does have a ton of dislikes, so you can assume it's going to be a little tricky for an easy problem, but I don't think it's too bad. Maybe the dislikes are just kind of from the long description and the way you solve this problem. But mainly we're given a non-decreasing order array. By non-decreasing order, they literally mean increasing order, or rather sorted in ascending order. So I don't know why they don't just say sorted in ascending order. It seems like they're purposely trying to be confusing, but if you take a look at this example input array, you can see it's sorted in ascending order. Now there are duplicate values, which is why they say non-decreasing order, because technically duplicate values are not ascending, they're, equal. But basically, our job is to take this array that could have duplicates and is in ascending order and then convert it into a new array where we remove the duplicates, right? So you can see we've taken this array and then removed the duplicates, and this is still in ascending order, right? It's still sorted, but now the duplicates are gone. And the difficult part about this problem is they want us to do this without any extra memory, so they want us to do it in place, right? So of course, if we're given an array like this one and we do it in place, we'll get the desired output, but we'll still have some extra memory in the input array, right? We'll have extra memory. It doesn't matter what we put here in the extra memory. That's just something we have to keep in mind. And the return value in this case is not going to be the input array. We're actually, for the return value, going to return how many unique values are in the input array. In this case, you can see 5 unique values, which matches what we have down here, right? 5 unique values, so we return a value of 5, but we also want to make sure that we update the array into this format. So we can't just return 5, we still have to update the array. So this problem is definitely best understood with an example. So remember when I said that we want to count the number of unique values? So how exactly is this problem going to work? For example, the first unique value that we read, where are we going to put it? Well, we want the output to also be in ascending order, sorted, right? So of course, the first unique value we're going to put in the first position, right? In index 0. The second unique value that we read, where are we going to put that value? Of course, we're going to put it in the second position, right? That's the only possible position we could put it if we want to maintain the sorted order, right? The third is going to go in the third position. The fourth is going to go in the fourth position, and the last unique value is going to go in the last position. Obviously, if we could allocate extra memory, this would be pretty easy, but we have to do it in place, right? We have to do it within the array. So really, when we say we read the 0th value, we're going to leave it in the 0th position, right? So basically, the first value in the array is definitely going to stay in that position. Now, the second unique value is going to go in the second position. Maybe we don't even have a second 0, right? That would mean that the second unique value is just going to stay exactly where it is. That would be simple. But in this case, that's not the case. So in this case, we have to put this value in the second position, which means we're going to go here. And of course, this 2 would go in the third position. So what we're realizing is it'll be good for us to go ahead and scan through the array with a single pointer, but it'll also be good for us to have a second pointer. We can call it the left pointer, which is going to tell us next time we see a unique value, such as let's say 3, where are we going to put it? Well, we're going to put it wherever the left pointer happens to be. By the time we get to 3 as a unique value, we want our left pointer to have been here to indicate that we already put a 0 here, we already put a 1 here, and we already put a 2 value over here. So this will definitely be doable if we have 2 pointers, right? One pointer scanning through the array, we'll call it the right pointer, and a left pointer telling us where we're going to put the next unique value. The left pointer will also tell us how many unique values we've already seen so far. So the left pointer will actually take care of the output parameter for us. Because every time we see a unique value, a new unique value, for example, we see 1, we're going to put 1 over here, and then we're going to take our left pointer, increment it by 1, and then put it in the next spot, right? So it'll tell us how many unique values we've already seen so far. So now that we know how we're going to solve this problem, there's just one catch. How do we know, as we're scanning through the array, looking at each value, looking at some random value, how do we know if this is a unique value or not, or meaning if this is the first time we're seeing this value or not. How do we know that? Well, just by looking at the picture, you might be able to determine it yourself. For example, if we saw this 1 for the first time, and remember the fact that this array is going to be sorted in ascending order, we can take a look at this value and compare it to the previous one. This is 0, this is 1. That must mean that this is the first time we're seeing a 1 value. What about when we get to this one? We'll compare it with this guy. This is a 1 and this is a 1. So of course, this is not the first time we're seeing a 1 value. We're just going to ignore it and then go to the next value. And by the time we get to the 2, we'll compare these two. 2 is not 1, so that's the first time we're seeing a 2 value. So it's actually not that difficult. So in the next 60 seconds, I'm just going to go ahead and do an example. So we're going to initialize both pointers left and right at the second value. Why are we doing it here? Because we know that the first value, we're never going to update this, right? It's going to stay exactly where it is. Now we're going to take a look at whatever value our right pointer is pointing at, compare it with the previous value. They're the exact same, so we're not seeing a 0 for the first time. That's perfectly okay. Now we shift our right pointer over here. Left is going to stay here because we never put anything there. Now our right pointer is here. Let's compare these two values. They're not the same. So that means this is the first time we're seeing a 1 value. So that means we're going to put this 1 value wherever our left pointer happens to be. So we're going to go ahead and put this 1 value over here. And since we put a value at the left pointer, we can go ahead and take our left pointer and then shift it over here, and also let's shift our right pointer as well. So now again, let's take a look at the value at the right pointer. They're the exact same, so we don't do anything. We can shift our right pointer one more time, exact same values. So again, let's shift our right pointer, and now we finally see a new unique value, right? Because this 2 is not the same as the 1. It's a new value. Let's put this 2 wherever our left pointer happens to be. Right now the left pointer is over here. Let's put a 2 over here. So when we do that, we remember we have to shift our left pointer. So this is the next spot that the next unique value is going to go at. So let's shift our right pointer again as well. These two values are the same, so we don't see a unique value. Right index is going to be here. Now we do see a new value that we haven't seen before, a 3, right? So the 3 is going to go wherever the left pointer is. That means the 3 is going to go here. Left can be shifted by 1 again, and right is going to be shifted again. Right is here. 3 and 3 are the same, so we shift right again. Now right is going to be here. 4 is a new value, right? It's not the same as 3. 4 is a new value. We can put 4 wherever our left index happens to be. Let's put 4 over here, and then increment left again over here. Let's also increment right. Now we went out of bounds, right? So since we're out of bounds, of course we know we can stop the loop. So what are we going to return now? What is our left index pointing at? What's the value of left? Left is at index 5, right? So we're going to return 5, just like the output wants us to do. And you can see that the values that are expected in the output is exactly what we have, right? We have 0, 1, 2, 3, 4. So we were able to solve this problem in big O of n time because yes, we're going to be having 2 pointers, but each pointer is just going to be iterating through the entire array once. So you can assume that the time complexity is something like 2 times n, which is exactly a big O of n, right? So with that said, we can finally get into the code and it's going to be pretty short. So first thing we want to do is initialize our pointers. Like I said, we're going to start at index 1. So I'm going to set our left pointer equal to index 1, and then I'm going to have our right pointer be iterating through pretty much every single value in the input array, which is what we want to do. But instead of having it start at 0, I'm going to have it start at 1. So basically both our left and right pointers are going to be initialized to 1. And remember, the only thing we need to check is the value that we're seeing right now, the value at index R, is this value a new value or is it a value we've already seen? How do we determine that? We can determine that by comparing it to the value that came before it at index R minus 1. So if they're not the same, that means this is a new unique value. What do we do with the new unique values? We put them wherever our left index is. So we can take this new unique value that is at index R and place it at index L, at the left index. And remember, every time we do this operation, we want to make sure that we remember to increment the left pointer. And we're only going to increment the left pointer when we do this operation. If we don't do the operation, we don't increment the left pointer. But we are always going to increment the right pointer, but I don't have to put that here because the for loop is going to handle that, right? That's why I don't need this line of code. The for loop is going to make sure to increment R each time. And once that's done, we have to return how many unique values are in the array. And we know that our left index can handle that for us. So we can just return left. Now you're probably thinking, what if we had an empty array of nums? Then wouldn't we want to return 0? And you're right, but for some reason LeetCode accepts this as well. So I think we're good to keep this code pretty simplified. So this is the entire solution. I'll run it to make sure that it works. And as you can see on the left, yes, it works, and it's about as efficient as you can get in terms of overall time complexity because this is a linear solution, no extra memory needed. So I hope that this was helpful. If it was, please like and subscribe. It really supports the channel a lot. Consider checking out my Patreon where you can further support the channel, and hopefully I'll see you pretty soon. Thanks for watching.